Okay, so when we're looking at double bonds, ethene has 2 carbons and 4 hydrogens. Propene has 3 carbons and 6 hydrogens. Hexene is 6 and 12. Nonene is 9 and 18. So we can say that the pattern is for every carbon, there's double the amount of hydrogens. When we look at triple bonds, how many carbons for ethene? Ethyne, sorry?
2.
2. How many hydrogens?
2.
Propine?
3.
And
4. 6. 4.
this is 4.
Isn't it 5? 5, yeah. 5?
Propine?
No, it's 1. No, it's 4.
Yeah, it's 4.
Yeah.
Because it's 2, 4, 10, 16.
Hexine?
6 and 10. 9 and 16.
And then, so what do you say that the pattern is?
2 and minus 2. Or C and then H. 2 and minus 2.
Okay. Do we all see how the patterns develop? So now you could be given just a standard, not if there's side chains, but you could be given this, and you could figure out the pattern. You could tell me the empirical formula. How many carbons are there? 1, 2, 3, 4, 5, 6. So if I have 6, then I know, and it's straight chain with no double bonds, I'm going to be looking at this formula. So if I have 6 carbons, I'm going to have 6 times 2 is 12 plus 2 is 14 hydrogens. Okay, if I threw a double bond into here, you would be able to tell me that that's 6 carbons and that it's 12 hydrogens. If I threw a triple bond into there, you'd be able to tell me that that's 6 carbons and it's 10 hydrogens. You would be able to tell me the empirical formula from a structural diagram or a line diagram without having to go through all the rigmarole of counting it out. Because there is a pattern. Now, if we have side chains, that changes the whole game. Okay? These patterns work for straight chains. Okay? You also need to know that aliphatic hydrocarbons what do we know about the difference between aliphatic and aromatic?
Aromatic smells like citrus.
Aromatics in like a benzene.
Is a benzene ring. Whereas these are straight chain. Okay? You also need to know saturated versus unsaturated. Okay? These are things you need to know. However you want to learn them, that's up to you. Alright. Summary of organic compounds based on boiling points. This is something else that comes up as a comprehensive question, like an application question in chemistry. And so this is the boiling points. This carboxylic acid has the highest boiling point, then alcohol. So this is the lowest. So let's arbitrarily give them numbers. So let's say this is 10. This would be 20, then 30, then 40, then 50, then 60 degrees. Okay? So alkenes, which are double bonds, have the lowest boiling point, and then alkanes, alkynes, esters, alcohol, and carboxylic acids. Okay? And this is when they're all the same amount of carbon. So if we had, let's go with propene. Okay, so it's still 3 carbons. Alkane, which is propane, is still 3 carbons. Alkyne is still 3 carbons. An ester would be okay. It's still 1, 2, 3 carbons. An alcohol, propanol. Propanol, you have to remember to do the bond line. So 1, 2, 3 carbons still. And carboxylic acid. So there's still a carbon here, a carbon, and a carbon. Okay? So there's still 3 carbons in each one of those. This has the lowest boiling point, and this has the highest boiling point. Okay? The other thing to note is that boiling points of aliphatic hydrocarbons are similar to those of, boiling points of cyclic hydrocarbons are similar to those of aliphatic, that if you have the same number of carbons. So if this was a cycle like this, it would have the same boiling point as 6. That. Okay? So the cyclic compounds are the same as their aliphatic compounds. Okay? When you're comparing compounds with the same functional group, we call that a homologous series. Longer the hydrocarbon chain, the greater the boiling point. And that goes all the way back to the very beginning of Chem 20, when we talked about the different bonding types. Molecular compounds only have London dispersion forces, or all compounds have London dispersion forces, but in nonpolar we see homologous series. Okay, so boiling points in a homologous series. Homologous means that there's the same number of carbons. So here, ethane, and ethyne have the same number of carbons. Okay, so ethane, propane, butane, pentane, hexane. These are all alkanes. We see that this follows the pattern. This has got the lowest boiling point, and this has the highest boiling point as we increase the number of hydrocarbons. Ethene to hexene, so 2 to 6. Lowest boiling point, highest boiling point. Ethyne to hexyne is 2 to 6, and we see lowest boiling point to highest boiling point. So as the number of carbons increase, your boiling point increases. Okay? Make sense? And then here's just the definition on a homologous series. Group of molecules that have the same general formula. Okay? Solubility of organic compounds. Alkanes, alkynes, and alkenes are not soluble in water because they've only got carbon and hydrogen bonds. Remember back to Chem 20, there's 3 functional groups that we can put on a hydrocarbon that makes it polar, makes them have fun. Fluoride, oxygen, and nitrogen, FON, makes them have fun. Remember that?
Oh,
No.
yes. I
Oh,
remember.
yes. Tell you these things for a reason. Okay? So an ester, if it's 4 carbons or less, it's soluble. If it's 4 carbons or longer, the carbons will tend to outweigh the benefits of having that oxygen group in there. Okay? Alcohol has the OH group in here, your hydrogen donator, and then your carboxylic acid. again your hydrogen so that you can make those hydrogen bonds, remember? To fluorine, oxygen, and nitrogen, strongest bonds that we got going. Okay, so we're gonna stop here. You guys are gonna work on these 6 questions. Where are we at for time? And we're gonna leave it there, okay? We'll take up refining structural isomers and refining process tomorrow. And then Friday we'll start organic reactions.
Ugh.
Yay, they're fun. They're fun.